Okay, Marta, can you tell me what problem you've drawn on your board there?
Okay, the problem that I was given is that a hot cup of coffee ended up, like, it cooled down when you put it on the table. So I created like an LOL chart where I have thermal energy and phase energy. I don't care about chemical energy in this problem. So I started out with 3 bars in the thermal account because the coffee was obviously hot, and 2 bars in the phase energy because it's a liquid. And here I show that energy is leaving the system because it cools down. And over here I have 2 bars in the thermal account because now the coffee is cooler, and still 2 bars in the phase account because it's still a liquid. It didn't turn into a solid or a gas.
Okay. Is this process endothermic or exothermic?
It is exothermic because energy is leaving the system, and I'm showing that like it's leaving via heating.
Okay. And how does your picture demonstrate the energy is conserved?
Because 5 minus 1 is 4, so energy is still conserved in like the system.
So tell me why you chose to use 3 bars to begin in the thermal account.
Because I wanted to show that this hot cup of coffee cooled down to room temperature in like when the reaction was done. That's why I started with 3, so 1 bar could leave.
Okay. How does the movement of the particles in the hot coffee compare to the movement of the particles once it's cooled down?
Here the particles move like faster. There's more interactions between the particles here because it's hotter. Then some of the energy leaves, and here the particles are still moving, but they move slower.
And what does that energy do once it leaves the system and goes into the surroundings? What does that energy do to the surroundings?
The surroundings, no, the energy that leaves heats up the surroundings. Like, we can feel like the heat.